Let's go ahead and get started. Our first one for the night, a fractions, decimals, percent based word problem. 1 minute and 30 seconds. Give it a shot. So, this word problem here really revolves around you knowing how to work with fractions, decimals, and percents. And again, based on the feedback from you all over in that form that several of you filled out, y'all wanted to see word problems dealing with fractions, decimals, and percents. So here we go. A quality control inspector noticed that 1 out of every 2,000 light bulbs produced in a factory are defective. 1 out of every 2,000. What percentage of the light bulbs produced are defective? Now, looking over in the comments, I see A's, B's, C's, and D's. Don't take this the wrong way, but I'm glad I did this problem because if I'm seeing all of these various answers, it's definitely something that we want to address. So, 1 out of every 2,000 are defective. And if we write this as a fraction, 1 out of every 2,000, that means 1 out of 2,000. This is our fraction. And something I want you to go ahead and if you don't know this, I want you to know this right now. If you ever have a fraction, you can always convert a fraction to a decimal very quickly by dividing. And it does matter what order you divide. You have to take the top number divided by the bottom number. So therefore, if we take 1 divided by 2,000, we're going to get 0.0005, a lot of zeros. And again, what I did there is I took 1 divided by 2,000, and this is going to be 0.0005. But here is all this is. All this is our decimal. Yet we want to find a percentage. We have this decimal 0.0005. You have to convert that decimal to a percent. So we need a percent, and there's 2 common ways you can do this. Either you can multiply your decimal by 100, which is the exact same thing as moving the decimal 2 places to the right. Whenever you multiply something by 100, all you're really doing is moving the decimal 2 places to the right. So we're going to have a decimal stuck right there. So this will be 0.05, and we finally have our percent. So I did see some B's coming in, but we don't want to pick B because this is saying this is 0.0005%. That is not correct because that's our decimal, but you have to convert that decimal to a percent, and therefore D is going to be our correct answer. Fractions, decimals, percents. Now this is a word problem, but it's very likely on the TEAS, on the math portion of the TEAS, that they could give you a percent and you may have to convert it to a fraction. They may give you a decimal and you have to convert it to a fraction. Let the calculator be your friend here. And just to show you that over here on the calculator, we have this decimal of 0.0005. That's what I have here. And notice if we multiply by 100, so times 100, notice we get that exact same number we have here. Just don't forget your percent symbol. D2P, absolutely, decimal 2%. It's one of my first videos I did for the TEAS. D2P, decimal 2%. I think it's, if you Google Brandon Craft, fractions, decimals, percents, you'll probably find it on YouTube. So there's one of those that was requested, and now we're going to move on to question number 2, a proportion-based word problem. And I'm going to say this, read the question very carefully. Give it a shot. A lot of B's coming in, that's good. Now this question could be worded one of 2 ways. Of course, it might not be cars, it might not be red things, but regardless, when you have this 5/12, 5/12 of the cars are red. So this dealership has 252 cars for sale on their lot. That's a whole bunch of cars. 5/12 of the cars are red. Here is another way that you could read this part of the sentence up here. This is another way that we can word that second sentence or the question to this problem. 5 out of every 12. 5 out of 12. Now, the reason why I'm mentioning that is it kind of ties a little bit into this, where we had 1 out of every 2,000. Of course, we're not talking about bulbs in our problem. So 5 out of 12 cars are red. Now, I'm going to show you just one way first, and then I'll come back and show you some other ways as well. Now, what we need to realize is that we are trying to figure out how many are not red, but even if you didn't see that yet, you can still get the problem right using this 5 out of 12. So what does this 5/12 represent? 5, there are 5 red cars out of every total 12 cars. Suppose you had a total of 12 cars right in front of your face. 5 out of those 12 would be red. That's what this sentence is saying. That's what this fraction represents. Now, if we're going to do a proportion, as long as I keep the red cars at the top and the total at the bottom, this is one of several ways that you can set up a proportion correctly. There are so many ways that you can set up a proportion correctly. So, we're trying to figure out 5 out of 12. Well, we don't have just a total of 12 cars. We have a total of 252. And if we solve this equation right here for x, or solve this proportion for x, let's be careful. So something I always like to do, just in case you have never seen this, is the fast way to solve a proportion. So whenever you have a proportion on the TEAS, go ahead and figure out which number is going to get multiplied by the x or whatever variable you choose. In this case, the 12 is going to get cross-multiplied by the x. Don't do it. Don't waste your time writing that down. Instead, multiply the other two numbers first. I'm going to take 5 times 252. Don't waste your time. Do not write that down. Immediately divide by that number that's getting multiplied by x. So if we divide this by 12, we're going to get an x value of 105. Now, sure, we do get 105, but we have to remember what 105 represents up here. That 105 is this spot. That represents the red cars. Be careful, that represents the red cars. We want the ones that are not red. So what we have to do, take your total of 252, subtract the red cars, 105 of those, and now we will have our total of 147 cars that are not red. Now, if you had picked D, you were on the right track, but that 105 represents the red cars. We want the ones that are not red. So, before we move on to the next problem, I want to show you an alternative approach. I'm going to tie in some percentages here, and this is actually the way I'm going to show you now. It's not as easy to understand, but it is the fastest way in my opinion. So, I'm going to take this problem, I'm going to duplicate this page, and we're going to look at this problem in a different light. Now, again, 5 out of every 12 cars are red, but we want the ones that are not red. Well, let's think about this. Since, if I can type, since 5 out of every 12 cars are red, ... here we go. Then the remaining 7 cars are not red. 5 out of 12 are red. So those other 7 cars that make a total of 12, 5 plus 7 is 12. If 5 of them out of 12 are red, the other 7 are not red. So that's one thing, one little trick right off the bat. But now watch what I'm going to do. I'm going to say this. I'm going to say 7 out of 12. Let's convert that to a decimal. So 7 divided by 12. Our decimal is 0.58 and then a bunch of 3s. Now, we don't necessarily have to convert this to a percent, but I'm still going to talk about that anyway. So if this is our decimal, our percent is somewhere around 58.3%. Think about this, y'all. 7 out of 12. 7 is a little bit more than half of 12, which is why we have a little bit more than 50% of the cars. 58.3%. Now, where am I going with this? Here's a fast way. So I took 7 divided by 12. Here's our decimal, which technically represents 58.3%. We can multiply this by the whole or the total number of cars. So if I multiply by 252, bingo. That's how you can get to that answer super fast. So again, what did I do there? I figured out the percentage of cars that were not red. We can multiply this by the total number of vehicles, or we can think of that as multiplying by the whole, and therefore we will get 147 cars that are not red. Same answer, but a different approach, a faster approach. But I do totally understand that can be hard to follow. Now, just to kind of throw this out there too, when you go back and look at these notes tonight, maybe go back and try the proportion approach that I did here, but instead do the 7 over 12 equals X over 252. That will take you straight to this 147 as well. So many ways to do it. Find what works best for you. And that's why I do like to show different ways, because everybody learns things a little bit different. All right, so the last one for tonight, if you've seen a problem, I think I've posted it over in the Facebook group. I have posted something on YouTube. Don't jump the gun. Read this question very carefully, and I'm going to give you 2 minutes for this one. Go ahead and give this one a shot. All right, so the problem that is similar to this is not dimensional analysis. This problem here is more along the lines of, if you've read a lot of posts in the Facebook group, every once in a while I mention making something up. Making something up. Now, there is a coins problem that I've seen pop up from time to time. And something I do want to show to y'all, if you're just getting started with TEAS math stuff and you've been over to my website, consider reading what this pop-up says as soon as you come to this page, because what I want to show you is I'm on a Mac. I have a MacBook Pro, so if I hold Command and F on my MacBook Pro, it'll bring up a search. And you can do this on any website, not just mine. And I want you to look up the word coins. This is the same type of problem, except in the problem you just read is talking about stones. Whereas down here we have coins. It's the same daggone thing. So search for that word. I do have a very similar video, and this is actually kind of goes along with my multiple choice review. That's another item that I have. That's not a free item. Of course, these videos are, but look for that coins problem for additional practice like this. So, to solve these types of questions, make something up. And you might say, well, how in the world am I supposed to remember to make something up? So notice that we are not given an exact number of any type of stone. Sure, we know Jackson's got some amethyst, some rose quartz, tiger's eyes, turquoise, and then we have, 6 times as many, 1/3, twice, but nowhere up here does it say Jackson has a certain or an exact number of stones. So if you don't have an exact number, make something up. And I'm going to show you 2 times that we can make up 2 completely different numbers, yet it's going to work out. So if we look at this first sentence that talks about the actual numbers of stones or something like that, he has 6 times as many turquoise stones as he does rose quartz. Taking that sentence right there, what does he have more of? He has 6 times as many turquoise as he does rose quartz. So therefore, I'm going to make up something for rose quartz. I'm going to call it R. And I'm going to say, hey, let's suppose he has, let's do 7. You can pick any number you want. So if he has 6 times as many turquoise, if we take the number of rose quartz and if we multiply it by 6, read this sentence again, he has 6 times as many turquoise as he does rose quartz. So his turquoise, I'm going to write TUR so we don't mix it up with the tiger's eyes, but 7 times 6, he would have 42 turquoise stones. Let's move on to the next sentence. The number of amethyst stones is 1/3 the number of turquoise stones. Now I said make something up. Once you make something up, don't be making up other numbers for the rest of the problem. You only want to make up one number and then use that to build the problem. So read this green sentence. The number of amethyst stones is 1/3 the number of turquoise. When you take a third of something, let's take our turquoise, let's divide it. We're taking a third of it, so we divide it by 3. Whoops, and I wrote a little 3 right there. So taking a third of something means we want to divide it by 3. So therefore, 42 divided by 3, that is going to give us 14. So therefore, his amethyst stones, he's going to have 14 of those. And then our last sentence, he has twice as many tiger's eyes as he does amethyst. So we just figured out that he has 14 amethyst stones, and now he has twice as many tiger's eyes as he does amethyst. So let's take our amethyst stones, let's double it, because he has twice as many tiger eyes. So tiger's eyes is going to be 28. Now, I'm making something up. Why did I make something up? Because we're not given an exact number of anything. Now, let's look at the question. What is the ratio of tiger's eyes to rose quartz? So tiger's eyes to rose quartz, a ratio, we can say, I'm going to let the TE, that's going to be my tiger eye. And sometimes you will see a ratio written with a colon in between it. So we would say tiger eyes to the rose quartz, which is the same thing as writing a fraction. And order is important. Order is important. Since it says tiger's eyes first, then rose quartz second, make sure you put tiger's eyes on top, rose quartz on the bottom, and let's write down these values. So tiger's eyes is 28, rose quartz is 7, and 28 divided by 7 or 28 over 7, yes, that is 4, but we can also write this as 4 over 1, which gives us this ratio of D. So I picked an odd number here for rose quartz. Let's go back and pick an even number, and sure, we're going to get completely different values here, but let's see what happens to our ratio at the end. So hang tight, let's go through this one more time, and then remember to search my website for the coins problem where you can get some more practice with this. So here we go. Let's pick an even number. I'm going to get crazy. Let's suppose he has 14 rose quartz. I'm just picking a random number, an even number. So he has 6 times as many turquoise. So let's take the rose quartz. Since he has 6 times as many turquoise as rose quartz, we got to multiply by 6, and it's a little bit too late for me to be doing that kind of math. What's that, 60, 84 maybe? 14 times 6? Yes. 84 turquoise stones. And I'm going to write TUR, just not to confuse with the tiger's eyes. Amethyst, what do we know about amethyst? 1/3 the number of turquoise. Turquoise is 84. We need to divide this by 3. We're doing the same math if you don't notice that. So therefore the amethyst, 84 divided by 3 gives us 28. And then last but not least, he has twice as many tiger's eyes as he does amethyst. Take our 28 amethyst, let's double it. And therefore he's going to have, 56 of the tiger's eyes? And now from here, 56, well, let's make sure we get our ratios right. We want tiger's eyes, so that's going to be 56. Let's write this as a fraction. Let's put our rose quarts at the bottom, which is the 14. And if you take 56 divided by 14, we should get 4, and we do, but when we write this as a ratio, we want to include that 1. 4 to 1 is that ratio there. It's a pretty cool technique, and this works for many math problems where you're not given an exact number of anything. If you're not given an exact number of anything, you can make something up and it will always work. And as I was sitting here doing this problem, it was the one that came back to me was this problem where it was like an employee at a store. They had an item for sale that all customers could do, like it was, say, 25% off, but then that employee got an additional, say, 10% off. And that does not equate to 35% off. But that's a problem. We don't know the exact price of that item, but you can make up any price. And you could take the 25% off, then take the 10% off, making something up. And yeah, so I hope that helps based on requests from you all. Fractions, decimals, percents, proportions, and ratios. And thank you all so much. Happy New Year, and I will talk to you all later. Take care.